Okay, welcome to a new lecture. In this lecture, we're gonna see about time varying field. Okay, so before we begin, as usual, we need to cover up some. What do you say? We need to have some basics and we need to revise back some stuff. Okay, so we know about Faraday's law. Now we have a new person called Lenz, and this topic is actually about Faraday and Lenz. Okay, now what do Faraday and Lenz tells us? Now lens is something that's opposing, so if you are going straight, it opposed to go back. It's something like inertia, it fight backs. Like if the object is stationary, you go push it, it will try to be in the stationary position back. Now why does it happen? Now Faraday says a changing magnetic field creates swirling electric field, where it says that magnet change creates electric. Okay, this is what Faraday said. But if you see here, magnet changes. Now Lenz say that this magnet changes fights back its position to be in the stationary. Like, okay, in the early it would be initial, then we have the new one. Now it will fight back to be the initial. Okay, this is what Lenz tried to say. Now the changing magnetic fields create a swirling electric field, and that electric field will always curl in a direction that fight backs against the change. Now this is what Faraday and Lenz try to say together. Now for the Faraday part, a changing magnetic field creates electric field. Now electric field will always swirl in a direction that fight against the change. So this is the Faraday law and this is the Lenz law. Okay, now if we see one by one, now Faraday tells magnetic field can produce electric current only if the magnetic flux changes over time. Now we know that Faraday said magnetic field can produce electric field. That is a base one liner. But if we expand it, we see here that Faraday said magnetic field can produce current only if the magnetic field change over time. This relates to the time varying field. Okay, now voltage is only induced in a loop when the amount of magnetic field changes over time. So this is a elaborated explanation. Now this is the simplest Faraday equation that we can get, where VEMF meaning the electric or simply the voltage. Okay, now the voltage is equivalent to this. What is this? Okay, this is the magnetic flux. Okay, this is the symbol for magnetic flux, and a D over anything meaning it changes. Okay, the differentiation means it changes. Now D flux means the changes in magnetic flux. Okay, now what does dt means? Changes in time. So the changes of magnetic flux over the changes in time, changes over time. Okay, now what is n? N is the amount of coil, or we say as the swirl around the circuit. Now what does the negative mean? Negative is the Lenz law. As said, it fights back. So this equation has the Faraday law, where the voltage is equivalent to the change of magnetic flux over the change of time with the amount of coil or amount of swirls with Lenz law. Okay, now we have three major part in Faraday law. First is transformer EMF. So loop stands perfectly, means you don't. Okay, for example, this is a loop. Okay, this is a loop. Now you have a magnet, you bring it back and forth. Now this creates electricity. Okay, it's not electricity but electric field. Now this loop stands perfectly, but you can change the strength of the magnetic field, meaning you can open it down. You don't actually put a magnet back and forth, but you connect it and maybe you connect it to the positive negative. Now this electric field creates magnet. So if you take higher voltage to lower voltage and high voltage to low voltage, the changes here makes the magnetic field change, so that creates current. Okay, now the magnetic field stays perfectly. The size of the loop is increased. Now you are connected to plus 5V, but you are increasing the loop, then you are decreasing the loop. Maybe both. Move the loop and magnetic field is changing. This is both. Now coming back, Lenz's law, what he said, nature hates change and it will fight back to keep the thing exactly the way it is, meaning it acts same as the inertia but for magnetism. What does inertia does? If an object is stationary here and the object is being pushed, it will try its strength back to be in the original position. Same happens in the Lenz's law. Now back to Faraday's law. A voltage is created when the magnetic flux passing through changes over time. Okay, as said, voltage is created when the magnetic flux changes over time, and this is something that you need, and Lenz's law. Okay, so again Lenz's law says that the direction of the individual electric current will always flow in a way that opposes the change in magnetic flux. You see, this is Lenz's law, it opposes. Okay, now Faraday creates the electricity as said with magnetic flux changes over time. Lenz steers the wheel that directs where it goes back. On nature rule that to fight back against change. Okay, inertia of magnetic field. Now this is something that you need to remember. At any exact coordinate in space, if a magnetic field changes over time, it will instantly force an electric field to start swirling around. So this creates if this happens. Okay, now what does stationary loop in time varying magnetic field means? The copper doesn't move, doesn't change. The magnetic field lines passing through the loop are changing and their strength over time. Transformer EMF. If you remember just now we talked about transformer, the loop stands perfectly, but you can change the strength of the magnet. So this happens. This is what we call as stationary loop time varying magnetic field, and we name it as V, transformer EMF. Okay, now we have a question that we can try on. Now if we see this question, okay, this question is an inductor is formed by winding and turns. Maybe okay, green is okay. Yeah, green is better. And turns of a thin conducting wire into a circular loop of radius A. The inductor loop is in XY plane. Center connect to resistor R. Presence of magnetic field is given, where W is the angular frequency. Find the magnetic flux linking a single turn of the inductor. Okay, before we begin, we notice that we have sign here, so immediately we need to know we are going to do a differentiation soon. So sine, cos, negative sine, negative cos. As said, this is the way for differentiating it, and this is the way for integrating it. Okay, don't forget it. And then they mentioned that circular loop of radius A, meaning circular loop radius A. So the area of the round circle is pi r square, where they mentioned that the radius is A, so pi a square. Alright, now the another thing that is given is the magnetic field is B naught y2 plus z3, and they mentioned that it's in the xy, so the changing part, okay, it's in the xy plane, but the loop is higher in the z plane, meaning the only thing that's changing is from ground to z. So z is changing, so the magnetic field depends on the z because it's higher depending on the loops count. Okay, now let us do question A. Now for A, we know that the differentiation is z. Why? The difference in the displacement of the coil is in z vector, z plane. Okay, now we also been given that the B is B naught y2 z3. If you guys remember, for dot product, y vector dot product z vector is equivalent to 0. Because why? Because it's in the different plane. But if z vector and z vector, it will create 1. Now in this case, we are going to do that B ds. So our B is B naught y2 plus z3 by z again. Okay, or we'll write this as ds. Okay, ds means it's a z, so we'll just write z ds. We know that y and z will become 0 and z will become 1, so this equals to b naught 3. Okay, so the whole equation would be this would be the whole equation. In the simplified equation, it would be b naught 3 sine ds, which is equivalent to 3 b naught sine ds. Does it finish? Not yet. Now we know that the circular area of loop is pi a square. Why? Now pi r square is the original, but they mentioned that the radius is a, so it becomes pi a square. Now we know that in order to calculate the flux, differentiate 3 b naught sine ds. Okay, so if we differentiate this, we will get the radius as only s. Okay, so if you only get s, the answer would be 3 pi a square b naught sine wt. So what happened was, we need to do s thus, so we need to times by 8. When we times, we have this as balance, so we need to integrate it. When we integrate only ds, we will get s. So our s was 0 to 2 pi, so we will be getting -3. Sorry, apologize. Sorry, it was 2 pi to 0, so you would technically be getting 3. Yeah, sorry. So you don't need to put the 2 pi there, you just need to have this. So this is the answer for A. So what they have mentioned is single turn. Okay, single turn. So for single turn, you need to calculate the ds times by the ds. So this is the vector, you only have 3 because 3 was in the vector of z. Then you calculate this by ds, so you only have to have the s here, so you have gotten it. Now let us try to do the question for B. What does B say? They have given the values now. Nice. Okay, before that, VTR EMF is equivalent to -n changes over time. Now the only stuff that we have is this. Okay, now if you see back the question, they have given us some values. Before that, let us try to solve this. So dt 3 pi a square b naught sine. Okay, now if we see the given value, n is equivalent to 10, b naught is equivalent to 0.2 t, a is equivalent to 10 cm, which is equivalent to 0.1 meter. You need to be familiarized with the SI units. Then w is equivalent to 10 power of 3. Now if we plug in this value, -10, so the differentiation would be yeah, I forgot to do the differentiation. Nice. So if you differentiate this, so differentiate over time, the only thing over time here is this. So differentiating sign would give us cos. So differentiating is here, so differentiating sign would give us cos, so this would become cos wt. So this will go on and we have negative n times y d balance. So we would be having this negative n 3 pi a square b naught cos omega t. Because why? Differentiate t, d over dt means differentiate this, meaning sin t being differentiated become cos. Now we have these values. Now plug in these values. Negative 10 3 times y pi times y a square is now 0.1 square times y b naught is 0.2, and you have cos 10 square t. Now if you do the calculation and all, you will get negative 188.5 cos 10 3t. So this is the VTR EMF. Now what happened? So we calculated the flux first. So by calculating the flux, we took this. So this Z is depending on the question. In this case, Z is the changing. So we had the B naught, then BDS, then we integrated it to find the DS, which is the area into here. Then we did our initial one. So d over dt for sine become cos. Then if we complete it, we'll get this. Now this C, what does the C? The polarity of VTO. Now see here carefully. What did Lenz law say? Lenz law said change in direction. Now cos 10 3t, or we'll just take cos t. Now imagine cos t, okay? If we differentiate or integrate, it will become sin t. So the changes is sin to cos, cos to sin. So if t is 0, cos 0 is equivalent to 1, sin 0 is equivalent to 0. So the initial was magnetic flux equivalent to 0. Okay, so eventually it was nothing, it became this. So at 0, t0, cos t0, it would become negative 188.5. Why? Cos 0 is equivalent to 1. So you just times it by 1, you will get this back. Okay, now for D, they mentioned that the induced current in the current is 1K. So we all know I is equivalent to V per R. In this case, our V is negative 188. In this case, you will be using the normal. I missed something. Now, if you remember your right hand rule, okay, if you remember your right hand rule, now the Z is upward, okay, so the Z is upward, the current is going through this loop. So technically the current is going through here. If it's going through here, meaning that the Z is pointing downwards. But in our case, the Z is now pointing upwards. When it's pointing upwards, the current is in its reverse position. So it will be going as such. When it's going by such, V2 minus V1, it happens in the another position. Okay, so V2 minus V1 is equivalent to the normal voltage. Okay, so what I'm trying to say, we got this because this is equal to V1 minus V2. Now when we are doing this, we are taking from the higher potential to lower potential, making that is changing this. So it would become 188.5 cos 10 3t. Right, so we are still using the Lenz law, but I skipped a part where you need to do the right hand rule back. Now it's just simple. I is going here, meaning that the Z was pointing downwards, but in our case now the Z is pointing upwards, meaning that the Lenz law had made it to fight against. When it's pointing upwards, it's going as such. If our calculation shows that it's V equivalent to negative 188, when we are doing, it means that V1 minus V2. But when we are doing our calculation, we need to go from the higher to the lower, so immediately this becomes the opposite. Okay, now back to here. So we know that V1 minus V2 is equivalent to negative 188. So V2 minus V1 is equivalent to negative 188.5 cos 10 power of 3t. Please write it fully. Now we know that I is equivalent to V over R. So our V is 188. This would become positive, sorry, 188.5 cos 10 3t, and it was given that 1 kilo ohm of ohm. If we divide it, we would be getting 0.19 cos 10 power of 3, and it should be in ampere because it's in volt. Don't even try to mess up with this, please don't. Okay, so this is what we'll be getting as the answer, and I hope we have made it clear, and that's all for today. So usually the cos, you just need to write it as such. So the answer would be come as such. Okay, this is the time, so this is the voltage unit and this is the resistor unit. Okay, thanks.